Alright, let's just do like 1, 2, 3, 4.
It's the ground.
Wait, so this is X, right? It's
Well, I got your
okay, so for the time we're doing 1 second, 2 seconds, 3 seconds, 4 seconds.
Okay, so my first question is, how did you come up with your equation?
I came up with the equation because it has to have negative 16x squared because it's a projectile motion equation. So I did y equals negative 16x squared plus 126x because that's the velocity. Oh yeah. And then the starting height is 0.5 feet.
Okay.
So I added that on the end.
Okay.
So that's
then we
how-
graphed it.
Yeah, we graphed it on Desmos here. So after 1 second, where's the one? Here, you could write it. Can you do x equals 1? Do what? No, see, okay, 110.5 feet.
So what does that ordered pair mean in context?
It means after 1 second, the ball, I guess, is at 110.5 feet.
Okay.
And then 2 feet.
Do any of you remember how to make a table
Oh, and here.
on Desmos?
Oh, yeah. Should go to like
62.5.
Oh, yeah, I forgot you.
Okay, so how do you do it, Bilal?
Settings table.
Okay.
Sorry. Okay. I did. So 62.5 after 2 seconds.
And then,
So what, this is question for Quinn. What key feature of that parabola is going to show you when it hits the ground?
the x, like the x-intercept.
Mm-hmm.
The zero x-intercept, the positive zero x-intercept.
Okay. Cool.
Okay, so I got negative 17.5 for 3 and negative 129.5 for 4.
Wait, what? Oh, yeah.
Yeah, you got that? Okay. Alright, write a standard form.
Okay, what does that question say?
How can Sarah adjust her equation to make the ball hit the ground sooner?
Okay, so what are the three parts of a projectile motion equation?
Oh, no, it's height, velocity, and
Like the effect of gravity?
Acceleration due to gravity. Will the acceleration due to gravity ever change on Earth? No, so that part can't change. So what are the two options we have for changing things? Height and velocity. So the first question says, what will make it hit the ground sooner? So what do we think could make that happen?
Change the velocity to be less.
So having a slower initial velocity.
Yeah.
Okay, so let's try to graph an equation that has the same acceleration due to gravity, the same initial height, but with a smaller initial velocity and see if that really does work. Did it hit the ground sooner? Mm-hmm. So what part of the parabola shows us when it hits the ground, Presley? The x-intercept. So what was the original x-intercept for our graph? 0. That was the initial height. When did it originally hit the ground? With the 126 feet per second velocity. Okay. And so when we adjusted the velocity, so Noella, you changed yours to 118 feet per second. When did it hit the ground this time?
7.379.
Okay, so a whole half a second sooner. So making the initial velocity lower makes it hit the ground sooner. Why does that make sense? Like in real life? Having a smaller initial velocity means you're throwing something harder or softer? Softer.
So it's gonna go, because you don't have enough power,
Okay.
or the same amount of power to throw it as far as you did.
Okay, cool. What do you think about initial height? How could that change the
Well,
parabola?
if it starts at like a lower height, then it might, or like a higher height, it might hit the ground sooner because of the initial velocity. If it's like realistic. Because like if you're throwing something off of a cliff, it's gonna fall quicker than throwing something off of a cliff.
Okay, cool.
And a couple of other things that last groups were struggling with. I'll come back to that in just a second. When we think about the projectile motion that we know, We are comparing two things. We're comparing time in seconds. Benna, are you paying attention? Time in seconds to the height of the object in feet. Several people in the last class were trying to use this equation to model the distance an object has traveled. We don't know that equation yet. That comes in Math 2, physics. That's not what we're doing. Our projectile motion equation is based off of time in seconds, height of the object in feet. Are we good with that? Okay. Second, when we think about our projectile motion equation, the standard equation is negative 16x squared plus the initial velocity times x plus the initial height. Unless your game is happening on a planet that is not Earth, the negative 16x squared is not going to change. That's acceleration due to gravity on Earth, right? So the two things, if your video game is on another planet, that's awesome. That can change. But if your video game's on Earth, the only two things you really have control over are the velocity and the initial height. So super fast, I want to hear some brainstorming ideas. How could the velocity change based on a game? Like what could cause velocity to potentially change?
If there's like a ball and the person who's throwing it is like stronger, so they would throw it harder.
Okay, so if you are having a video game where you can like pick your avatar, maybe some avatars are stronger, some are not as strong, that could impact the velocity an object is thrown at.
So projectiles, how do they relate to the purpose? I see that you're gonna have 1, 2, 3, 4, 5 planets, like 5 settings. So are you just finding what those acceleration due to gravity is for each of those 5?
Yeah, so we have the equation first.
Okay, so this slide is showing you how the first term of your projectile motion equation changes. Okay, so then, okay, now what are you guys talking about? Slide 5.
What would be like the
So what's getting, it's the litter stuff that's getting thrown, right?
yeah.
So I would just Google, is it like a game, like a mobile game, like on a video game console, like the Wii?
Anything. Or like,
Yeah, we're still trying to figure it out. I would feel like maybe like the Wii would be like the best. Cause like
well, or mobile, because if you
Because then it couldn't be different.
No, but if you think about Retro Bowl, like I know that's off topic, but it's like the actual motion of like you swipe back and the ball goes.
yeah.
You know what I mean?
So we're thinking mobile game.
Yeah.
So then I would just search like average velocity that a baseball gets thrown, or like pick a similar sized object maybe and just search it and use that to pick.
I think like a hockey puck would be good.
Okay. Hockey puck. So it's 26 something milliseconds.
Yeah, so
Or well, you can't really throw it.
I mean, you can't. I think that's like meter. No.
Average baseball is thrown like 93 miles an hour.
I don't think we'll be going that far.
I know.
I think we should do like, if you, what is like an average, search up like an average person throws a baseball. Not like a baseball player, but just like in general. What would like an average,
Well, that's not the speed.
So,
or velocity, yeah.
oh wait, hold on, give me 1 second, my slides are up. Okay, so remind me again the premise of the game.
We have it on slide
2.
So I'll just, yeah.
Okay, so open world, it's for connectedness, and it's sports.
A big part of it is the mini games.
Okay, so what was your question?
My question was about the slides 5 and 6 where you're supposed to write the equations. I did the whole short guy but he's strong with the higher
Ooh,
velocity.
I like it.
I did
Okay.
all of that, but like what am I supposed to put as far as an actual equation?
So you have an equation.
Oh.
You have, so the negative 16x squared is the same for both. That's acceleration due to gravity. So I see the stronger player has a higher velocity,
He does 10.
but a smaller starting height.
Yeah, and Miss West told me to make it realistic, so I put 3 feet.
Okay. I might look up a more realistic velocity because 10 feet per second is pretty slow.
Okay.